Hi, everyone. You're listening to episode 696 of the People Behind the Science podcast, and I'm your host, Dr. Marie McNeely. Today, I am looking forward to revisiting our conversation with our guest, Dr. Sapna Sharma, originally published on August 22nd of 2016. Listeners, Sapna's research examines the effects of environmental stressors like climate change, invasive species, and pollution on lake ecosystems. Her work has helped improve our understanding of how different organisms and communities respond to these stressors, and she has developed quantitative frameworks to predict the effects of environmental stressors on ecosystems. And in this episode, she shares more about her life, her career, and her work. So listeners, get ready to meet another great researcher in this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of People Behind the Science. Today, I am thrilled to introduce you all to Dr. Sapna Sharma. So, Sapna, thank you so much for joining us on the show today. How are you?
I'm great. Thanks for having me on your show.
Wonderful. Well, we are delighted to meet you and learn a little bit more about your life in science. So, listeners, Sapna is an associate professor in biology at York University. She received her PhD in ecology and evolution from the University of Toronto, and she completed a postdoctoral fellowship at the University of Montreal and the Center for Limnology at the University of Wisconsin-Madison. Sapna served on the faculty at Loyola before joining the faculty at York, where she is today. And Sapna is also the founder of a science outreach program at York University for refugee children called SEEDS. And Sapna is here with us today, listeners, to talk about her life and science. So we want to get to know you, Sapna, both as a scientist, but also as a person. So can you start by telling us what you like to do when you're not doing science?
So I had a baby recently. I have a 14-month-old son, and the last 14 months have really been spent with him when I'm not doing science.
First of all, congratulations on the new addition to your family.
Thank you.
What are the activities of choice with your 14-month-old?
We do lots of different things. He likes going to music classes and swimming classes, and every day it's just something different. He just learned how to walk this last week, and so that's been really fun.
Exciting and terrifying, I think.
Yeah, exactly. He's just a really relaxed kid who's really curious, so it's been super fun hanging out with him.
Well, that is awesome. Great to get a window into your life outside of science. But I do want to chat a little bit about your scientific side as well. So can you tell us how you describe your work to someone who may not be familiar at all with your field?
The way I describe myself is somebody who studies the effects of climate change, invasive species, and pollutions on lakes. Just pretty simply, I work on what affects lakes and how it might be manifested through water quality or fish populations, or just looking at the effects of climate change on lake ice or water temperatures and water quality, for example.
Very cool. I like how you have a really nicely packaged description that is digestible for everyone. I think that's really important.
Yeah, thanks.
So now, can you tell us a little bit about what motivates you? I imagine right now is a crazy time in your life with a young kid, balancing your faculty position, your research, all the things you like to do outside of science in your life. Can you tell us what keeps you motivated, and do you have a favorite saying or quote or a motto that keeps you going?
One quote that I really like is, "We're all smart, but distinguish yourself by being kind." And so I think I like to keep that perspective when I'm at work or I'm at home or with friends or family, that everybody's smart in their own way, but you can sort of make a mark in the world by being kind.
Definitely. Well, I think that kindness is so important and something that kind of connects you to humanity as a scientist.
Exactly.
So now, can you tell us a little bit about some of these people who you might have encountered along your path who served as role models or people who you've looked up to?
There's lots of different people, I think, that you come across at different points in your life that are role models. As a scientist, one of my role models is Dr. John Magnuson at the University of Wisconsin-Madison. And actually, one of his papers was one of the very first papers I read as a student. And it's sort of, his work has really influenced all the different aspects of my research, working on climate change, working on fish, working on lake ice and water quality and long-term data. And so it's sort of, whenever you think about the seminal papers in my field, it always goes back to John. And I've been really fortunate to get to know him as a collaborator and a friend. We met at a wedding once, and then he served as my external for my PhD defense. And then during my postdoc in Madison, I got to work with him quite a lot, and we still work closely together. And so it's been really wonderful to learn from him and how he shaped the field of ecology over decades.
Well, I think when you have these figures that you look up to in your mind, it's easy to build them up and then you're almost intimidated to meet them. Do you remember what it was like first meeting him?
The first time I actually met him was at somebody's wedding, and we were on a boat. We were going to the Toronto Islands, and we were on a ferry, and I was like, wow, that's John Magnuson. But I went up to him and spoke to him, and he's a really kind person, pretty easy to talk to, and very friendly and caring. So it really, just his personality made it easy to approach him and build a relationship with him afterwards.
Definitely. And coming back to that theme of kindness, I think is really important when you're a mentor then for other students, for other people in your field. So very cool. So can you tell us a little bit about what sparked your interest in science? Can you think back? Is there one memory that really sticks out in your mind of where your journey started?
It's kind of interesting. In grade 7, I did a science fair project on climate change and how climate change affects plants. I was growing some plants. And then grade 8, I was working on acid rain and how that affects plants as well. So it was interesting that even though science and ecology wasn't really a big aspect of my life in elementary school, it really stuck out as something that I really enjoyed doing and had science fair projects on it. So when I was younger, I actually was a tennis player and I played competitively and I played for Team Canada. And so my life was really as an athlete, and science was something I did for fun. And so it's kind of nice that as I grew up and I had injuries that ended my career, that I had science to fall back on, which was pretty awesome. And it sort of stems from my time in elementary school that I was interested in the environment.
Oh, that's really cool to look all the way back and say, even at that young age, you were interested really in a field very close to what you ended up studying in ultimately.
Yeah, exactly. And then in undergrad, I just had some fantastic professors in ecology and evolution and statistics. And so that sort of really piqued my interest in furthering my work in that field.
So then can you tell us what took you from this undergraduate student being inspired by some of the people you're working with to where you are today? What are some of these key moments that really helped you get your current position?
Well, first I went to graduate school at the University of Toronto, and that really helped inform who I am as a scientist. And I was in a lab during my master's looking at water quality and fish populations in Lake Erie. And then for my PhD, I transitioned to working on climate change and how it affects water temperatures and fish populations. And working on climate change directly was something I was always interested in. So during my PhD, it was awesome to actually be able to research that field. And then I chose postdocs based on different skills that I wanted to gather. And so I wanted to work on spatial statistics. And so I went to Laval briefly to do some spatial statistics on caribou. And then I went to University of Montreal and worked with some really great ecological statisticians and fish biologists. And that really helped bring out more of the statistical aspect. And then I sort of wanted to bring in the biology back into my life and went to the Center for Limnology. And that was one of the best experiences in terms of education that I've ever had. And it was so wonderful to really grow as a scientist there and become independent. And then I ended up being a professor.
Certainly. Well, you made it sound easy there, Sapna.
Well, I remember during my PhD proposal, they asked me what I wanted to do. And I said, I don't know what I want to do, but I definitely don't want to be a professor.
Really?
And so, yeah, it was just that was the one thing I knew I didn't want to do. And somehow being an academic kind of brings in all the different aspects that I really like. Like I like teaching. I like working with students. I love the research. And so you get to do all those different things. So it sort of worked out great.
Definitely. I think there's a lot of variety and perhaps more than I even appreciated when I was a graduate student. Now that I'm sort of seeing it from the other side as a faculty member. So.
Yeah, exactly.
So I love this point that you brought up of planning what postdocs you wanted to pursue based on the skills you wanted to gather. And I think that's a great strategy. I know some people are sort of lost when they're trying to decide where they should go next.
That really worked out well for me because you can work with people who are amazing in their fields and learn from them when you're with them for a year and a half or 2 years. But then when you start your own faculty position, I think it really helps to have a broader perspective than what you had as a graduate student. And especially, I was just going through the tenure process. They always want to know are you different from your PhD advisor or your postdoc advisors? And having all these different experiences really makes you independent and different from everybody else.
Certainly. So now that you are at York, you have recently been promoted to associate professor. We're excited to congratulate you on that.
Thanks.
Can you tell us about something you're working on that you are so excited to be working on?
A particular project that I'm super excited about is looking at how lake ice has changed around the Northern Hemisphere. And so we've been looking at it, for example, in the past 50 years, in the past 150 years, and up to the past 570 years. A recent paper that we just published looked at how ice has changed in two systems. One was in Japan, collected by Shinto priests, actually. They looked at when the lake froze and collected the data since 1442.
Interesting.
And then another time series was collected by merchants in Finland since 1693. And so we can get an idea of how climate has changed before and after the Industrial Revolution and extreme events. So we're going to build on that project and look at how ice may change into the future, because lake ice is so important, for example, for transportation, for a sense of culture, ice fishing, all these recreational activities, but also for a lake. And so we don't really have estimates on how it might change in the future under climate change. So we're currently putting together a data set of about 250 lakes over the last 70 years so that we can start doing some predictions and forecasts how it might change into the future. So I'm particularly excited about that. And you mentioned in the introduction that I'm also leading an organization called Seeds, and it's really picking up this summer. So the reason I started this organization was we all know about the migrant crisis in the Middle East and Africa. And Canada actually took a stance and they said, we're going to bring in 25,000 Syrian refugees into Canada. And a lot of them are coming into Toronto. And I think a lot of people in Canada are trying to figure out how they can help.
Sure.
So there's lots of people sponsoring families and doing fundraising to bring families in and get them set up. Mm-hmm. And I thought it'd be nice to work with the kids directly and try to welcome them into Canada so that they can feel like they belong here and they're welcomed here. And so what we do is we work with an immigration center in Toronto, and these immigrants are government-sponsored refugees, so they don't have people in the community necessarily planning things for them and supporting them, and they come from all countries. So we work with families from Syria, Iraq, Iran, Afghanistan, Somalia, Eritrea, Burma, and so wherever they come from. And they normally come to this center, this reception center, for about 1 or 2 weeks while they set up to get housing and their health card and all those things. And they come with kids. So on Saturdays, like once a month, once every other month, we take the kids on a science outreach trip. We've been taking them to science fairs, and we've been taking them to natural history museums and science centers and sort of doing science outreach with them. And we develop activities for them. And actually, one of the great things about being at York is that York is incredibly diverse. We need translators because they don't speak any English. And so we contact the graduate students. And we have gotten so much support from people who are willing to spend a day and translate for these families so that we can do these outreach activities. And we get our outreach activities translated to Arabic and Farsi, for example, so that they can learn English as well and get English translations and Arabic translations. And it's been really great. We've gotten a lot of community support to do this. So this is another activity that's not directly related to my science, but science outreach that we're really ramping up right now.
Well, Sapna, you brought up so many phenomenal things that I want to touch on. So let's start with this SEEDS program. Can you tell us about how many students are involved or how many children you've been able to impact?
So far, we've impacted about 85 students.
Wow.
And every other month we get more. So it's pretty nice. We rent a school bus. It's normally mothers with their children, and we just put the mothers with their children on the bus and we do science with them for a day. It's really great, but it's also very challenging emotionally for us. So we're also working with the psychology graduate student body who are developing sort of sensitivity training for volunteers when you work with at-risk populations, just because they've gone through so much hardship to get to Canada. it can be pretty challenging to reconcile that these people, these poor kids, have suffered so much. And so we like to just give them a great day. And so far, it's been really awesome. Like, they're even excited just to go on a school bus. Right. You get them on a school bus and then you take them through the city, and they're just like so in awe to see what the city of Toronto looks like, and take them to the science activities, and they're just like, I don't want to leave. This is so fun. And you take them to the next activity and they're just so enthusiastic because the next thing is even more amazing than the first thing they saw. So we're trying to create a community for all the new families who are coming because they're interacting with one another and playing together. And we hope to build a community for them.
Well, Sapna, I think this is an amazing program and an amazing way to bring people together and, like you said, form those communities. So I really appreciate your efforts in this SEEDS program. I think it's phenomenal.
Yeah, it's been really great. And it's been great to actually do something small that you can try to help with this crisis that's going on globally.
Absolutely. So now you also mentioned in talking about your research, some of the amazing work that you're doing on lake ice. And I think something that you sort of snuck in there was the fact that you are working with data that has been collected since the 1400s, the 1600s. And I think this is amazing as well. So can you tell us, what is it like looking through these records from hundreds of years ago, documenting changes in lake ice?
I think that's why I find this project so interesting, is because it's not just about ecology. It's so interdisciplinary. We have to learn about climate change and paleo records and also history. And we work with a whole group of translators. So with this Japanese lake, I can tell you a little bit about the history there. It was started by Shinto priests, this record, in 1442. And the reason they started it was because they're on a lake, Lake Suwa, and it freezes every year, and there's this ridge that forms. And in their tradition, what they believed the ridge to be was, so there was a god and a goddess that lived together in a shrine. Mm-hmm. And sometimes what happens when people live together for too long, they got into an argument and the goddess moved out. And she built herself a shrine on the opposite side of the lake. And so the god would cross the lake when it froze with his dragon every year. And so the ridge that was left was his footsteps with the dragon crossing to visit the goddess. And this event was celebrated because every time they observed this ridge, they could make predictions about, for example, what the climate would be like the following year and the rice harvest. And they found that actually the years when the lake did not freeze, they were correlated with famines. And so learning about this and going through all the Japanese literature with translators was really cool. And my collaborator went to Japan and worked with a Shinto priest to go through the rice paper and go through all the dates that the lake froze. But it came with challenges because the calendar changed in the 1800s.
Oh, no.
They went from a lunar calendar to a Gregorian calendar. And when you're working in climate science, the date that the lake freezes is very important. But then the calendar changed.
That is the critical data.
Yeah. And that was like right in the middle of the Industrial Revolution as well. And in Scandinavia, the calendar changed as well. But they dealt with it in a systematic way. They just add some days to a year or add a week. But it was systematic, and they did the same across the country in Finland. But in Japan, it depended upon the shrine that you were at, how they wanted to deal with the calendar change. So some dealt with it very differently than others, and there weren't very good records of it. So that created a huge challenge for us. But you learn a lot about history as well, and land use in the region and deforestation as well. And all those things impact the climate that we could observe through lake ice measurements.
Very interesting. Well, I think with this story, you've kind of hinted at some of the challenges that you're facing in your research today. And I think talking about these challenges is really important, not only to prepare students or future scientists for what's coming down the pipeline for them, but also just to show people what life as a scientist is like. It's not easy all the time. So can you tell us a little bit more about another one of these challenges that you face, or maybe a major failure that you've had and how you get through them to be successful?
So yeah, the calendar date challenge was a scientific challenge that we dealt with by being very conservative and not making some projections about how the climate has changed in those years. Mm-hmm. Because I think it's better to err on the side of caution rather than make these grandiose claims when you can't be sure. One major struggle I had was with my first postdoc. So I did a brief postdoc in a small town in Quebec. And the major challenge that I had was not science related. It was more racism related. The culture wasn't so welcoming for Anglophones and people of different cultures and color. And so That was really challenging because I'd go to work and people would blatantly say racist things to me at lunch most days.
Really?
Yeah.
Wow.
And I go home and people would say racist things to me as I was going home. So it sort of was a really unexpected coming from Toronto, which is so diverse. Mm-hmm. And it just wasn't what I was expecting. But the way I sort of dealt with it was I started forming groups with people. So it turned out there was a whole bunch of people that were being marginalized.
Just sad, but helpful, I guess. Yeah.
Yeah. And so somehow I found them all. And then I created like sort of a social group for us and a support network. And that really then changed the experience because you had other people going through similar things. And then the other thing that happened was I had a support system back home. So one of my colleagues, he invited me to give a seminar at the University of Quebec at Montreal. And there he invited two people who would later on become my postdoc supervisors at the University of Montreal and University of Wisconsin-Madison in a way to help me leave a situation that was tough. The lesson that I gained from that is it's important to have a support system, but also if you're in a situation, I think students feel this, or anybody can feel this, that they're in a situation that they don't really like. Sometimes they'll just stick it out because they think it's them or they don't know if they can do anything. And if it's a situation that you can't resolve at all, that you always have other options of places that you can go.
Well, Sapna, thank you so much for sharing this difficult story. I think oftentimes when we think of scientists, we envision them as these objective voices of reason. But I think every field, science is not exempt. You have these instances where there are terrible environments to work. There's prejudice, there's problems. And I think you really handled it well. You built that support network to help you during this tough time. You also leveraged your network to find a way out. And I cannot emphasize enough the importance of a strong scientific community and network. And these things can really help you when you end up in a tough spot.
I think that's exactly true. And I think it's important to talk about it. I wasn't sure if I would mention this because I talk about it with students. My lab is mostly composed of underrepresented people in science. Mm-hmm. I talk about things like this with them because they go through similar things, even though it's years later. Being a woman and not being white, you sort of have additional challenges to face that you might not necessarily get if you're a white man.
Certainly. Well, again, thank you so much for bringing up these important topics and giving our listeners out there who might be going through a similar scenario ways or ideas for them to get through it or get out of it. I think that's so important.
Definitely.
So we don't just want to talk about your tough times, though, Sapna. I do want to talk about your happy days in science. So can you tell us next about a success story? And it can be either a big success or even just a little win that meant a lot.
Recently, in this past year, I've been fortunate enough to publish some important papers that have gotten some attention. And so one is looking at how water temperatures have changed globally. And the other was the story that I mentioned about the lake ice and how it's sort of giving us an idea of what the climate was like before the Industrial Revolution. So this global water temperature study has garnered so much media attention from around the world. And it's been like a large scale study. And we've shown that lakes are warming at faster rates than air temperatures and oceans. This first global synthesis of how lakes may be responding to climate change with respect to surface water temperatures. A really cool thing that came out of it. It was featured on the front page of the Toronto Star, and on there they had this new iPad app or something. Mm-hmm. But then one day I was just like walking to the subway station and going to work, and I saw the results of my study in an ad, actually all over the subways, all over the buses and the streetcars and all the bus stands in Toronto and the whole greater Toronto area, that the Toronto Star is focused on using our research as their advertisement for their new app.
Oh, wow.
So it's really cool because you can see like they've summarized the major findings of our result and they have some images, and that's been pretty fun. And like you get to ride the bus and the subway and you get to see your work plastered on the transportation that you're using.
You feel like a celebrity. Yeah.
Yeah. Nobody knows it's something that I did, but it's still really cool to see it.
That is awesome. Well, you mentioned that a lot of your work has recently been gaining attention. I know a lot of scientists struggle with communicating their work to the public or maybe communicating their work with media. Is this something that you found that was difficult for you, or was it pretty natural?
Well, it's difficult and natural in different ways. As I mentioned, I used to be an athlete. I've been getting interviewed since I was a kid because of tennis. And then as a graduate student, I became a science correspondent on a radio show looking at environmental news across the country.
That is awesome.
And so that came into play. In our group, we've been getting some media training as well, and science communication training. I don't think that I'm very good at it, but I enjoy talking to people about science and other things. But I'm learning a lot on how do you communicate science to the public. And the workshops that our group has been undertaking have been really helpful to get an idea of how do we communicate our major findings. And we did that for the water temperature study, which I think really helped because we had a concise message that we were taught how to communicate.
Definitely. Well, Sapna, I think you were doing a great job with the communicating so far in our interview. So
thanks.
Practice and the training has paid off. So I think that is fantastic and so important to communicate your findings. And now you mentioned this global water temperature study, which is an exciting success. It sounds like you were pulling data from everywhere, right? From all sorts of different places. Do you remember that moment where you kind of got all the pieces together and saw the big picture?
This project has taken forever. It was a 4 or 5 year endeavor. Mm-hmm. So we've been seeing the big picture for a while, but it's just, there's all these different layers. So that was another challenge because we had 291 lakes that we put together globally. And we had over 80 contributors from 20 different countries involved in our project.
Oh, wow.
Which was fantastic because you get to meet wonderful people and you get to learn about their lakes and their regions. But it also presented a challenge because you have to put all those data together and see how did they fit with one another. It was definitely challenging in that respect, but also exciting because all of a sudden we had this global database in which we could do a global synthesis. And we found really similar results. We found that 90% of the lakes were warming, and the ones that were cooling because of land use changes. But what I really liked about the study was that, say we're in Ontario, that lakes right next to each other would be warming at similar rates, and it's sort of a regional thing. But it really wasn't. It was more about the climate characteristics and the lake characteristics. So lakes in Ontario were quite similar to lakes in Finland and Sweden. And it brings in this global perspective that your lake can be unique, but it really fits into this global pattern of how lakes work. And that was a super exciting thing for us when we saw that.
Certainly. It's sort of the idea of you're not just discovering an independent observation. It's almost like a rule of nature of how these changes are happening.
Yeah, it was really cool.
Well, fantastic to hear more about this study. And I know as a scientist, you're often immersed in the literature, trying to keep up with all the journals, all the publications coming out in your field. But it's nice to escape sometimes from the scientific reading to enjoy a good book. And I love passing on book recommendations to our listeners. So Sapna, is there a book that you can recommend to us today to add to our reading list?
So as I mentioned, I have a 1-year-old and I read to him a lot. So I've been reading One Fish, Two Fish, Red Fish, Blue Fish quite a bit.
Solid choice.
It's a great choice. I also recently read Chris Hadfield's book, An Astronaut's Guide to Life on Earth. And Chris Hadfield is a Canadian astronaut who was a captain on the International Space Station recently. And he shared his life journey to space. And it was a really inspiring read for me because here's a person from Ontario who's gone on to go to space and do such wonderful things and such diverse things. But he just talked about his journey to get there by working hard and trying his best. And even if there were barriers, for example, when he decided he wanted to be an astronaut, Canada did not have a space program. But still, he was determined and he tried to figure out which path would be the best for him to achieve his dreams. And so I really like that book. And it comes sort of with a companion book of photos that he took from space. It's just a beautiful compilation of different parts of the world and sort of a different perspective on life on Earth through the lens of an astronaut in space.
Well, that sounds awesome. I'm going to have to add that to my reading list.
It's a fun book.
Absolutely. And I kind of like these stories that take you through an actual real live person's history and the things that they experienced and showing their perspective. So fantastic recommendation. Now, we mentioned space travel, and unfortunately you haven't been able to travel to space, but I think as a scientist, you get to do quite a bit of travel. So can you tell us about your favorite travel memory or a place that science took you that was your absolute favorite?
It's really hard to choose because, as you mentioned, as a scientist, you get to travel to really cool places. One memory that sticks out is going to Nanjing, China. I went there to give a plenary lecture for a mathematical group looking at water quality problems in Tai Lake. So Tai Lake is the third largest lake in China, and it's incredibly polluted. You can actually, if you go to Google Images and satellites, you can see the algal blooms from space.
Oh, wow.
There's 90 million people in the watershed, and their problems are just at such a different scale. So it was a really remarkable trip because we went to China, we met people who are working on this lake and living in the watershed, and just understanding how important lakes are to people, but also how important it is to manage a lake so that it doesn't become such a huge problem with eutrophication and pollution and toxic algal blooms. And then Nanjing itself was beautiful. Seeing the region, I had never been to China before, and the people were so warm and friendly and took us to see all these different temples and see their culture and markets, and it was pretty fantastic. So I think that was one of my most memorable trips.
That sounds wonderful. So how long were you there?
3 days.
Oh,
so not
wow.
I was teaching when I had first started at York, so I was still teaching quite a bit. So I could just go over a long weekend so that I could make it back for class. But we did a lot of things in that short period of time.
I was going to say, it sounds like you packed a lot into 3 days.
Yeah, we did.
Forget the jet lag. There was no time for it.
There was no time for jet lag.
Well, great to hear a little bit about one of these travel memories. And I love that you brought up the people who you met there. They were so warm. They were kind. Being able to work with these amazing people as scientists, I think is such a great opportunity, not only when you're traveling, but also your colleagues at home. And I know there are stereotypes out there about what scientists are like. And we love to break those on our show because I think there are so many different types of people in science, so many different personalities. And sometimes those manifest with quirky traditions or just funny memories that you guys share together. So can you share with us, Sapna, one of your own stories of the human side of science that showcases these different personalities or quirks?
That's a really tough question, but just what you mentioned about people having this image of scientists and being at York, it's kind of nice because it's a diverse population and I'm a young woman. The girls in the class are like, wow, if you're a scientist, I can be a scientist too. You don't have to be the old white bushy haired man.
Right. Elbow patches and
yeah, exactly. So a random thing in graduate school that happened in our lab was we had these really old computers. So my supervisor finally bought us a new computer, and it was a state-of-the-art computer at that time. And we used to have a network between all of the computers so that we could share our data and go back and forth, depending on the computer we're on. But for some reason, I couldn't access this computer at all. And that was supposed to be my computer. And then we got a message, and my computer's name was Lakes. Yeah. And people would come up to me and say, why are you always sending me viruses? Like Lakes keeps wanting to share. Like, so my computer was always sharing viruses with people. And then it turned out that it was the third most active computer on campus, and people had broken into the computer and were using it as a server to distribute viruses and
oh my gosh.
So it was like, wow, we have this computer, we can't really make it work, but somebody outside our lab is really using it for different purposes.
Nefarious purposes. Yeah.
Yeah, exactly.
So then what did you do? How did you rectify this?
I don't know what I did. I don't know.
Turn the computer off. It's done.
I think I graduated and it's somebody else's problem.
Yep. That is another wonderful thing about science, especially the early stages of your career. You're kind of moving through all these different places and you're never there long enough to have to deal with the aftermath sometimes.
Exactly.
Well, wonderful to hear about one of these funny memories of yours. And I love that you named your computer. I think that's awesome.
Yeah, we all had names for our computers.
Yeah, I'm going to have to adopt that. My computer is thus nameless at this point.
Oh, really?
Yeah, need an affectionate name for it.
Exactly.
Well, I think this was a great story to showcase just some of the funny things that happen in science. And I think when you're with scientists, not only do you talk about these funny memories and do fun things together, but it's fun to talk about the big questions. If we didn't have any limitations, if things like funding, staff, technology, feasibility, the things that normally limit our thinking were out of the window, I love chatting with scientists to hear about the big problems that they would want to address, those big questions that are in their minds. So Sapna, can you tell us today what a big question remains in your mind?
I think one big question that I'd like to start going towards is thinking about how climate change may impact water quality around the world. Sort of like, how might it impact toxic algal blooms and availability of clean drinking water and potable water to use? Because I think that's, in Canada, we have a ton of lakes. We have so many lakes, we don't actually know how many we have. We have between 3 and 7 million.
Oh, wow.
So we have a lot of water here. And when you go north, it's a pretty pristine environment. So we have a lot of clean water, but many other places don't. And I've heard people say that currently wars are fought over oil, but in the future they'll be fought over water. And I think thinking about, in terms of research, how do we make sure that the water that we do have left is clean water and potable water under these extreme climate scenarios and extreme climate events? And so I think that's what I'm interested from the scientific perspective I'm working on. And it would be really great if there could be recommendations or management strategies and policy that we could then work towards to making sure there's clean drinking water in lakes around the world.
Well, I think that is a great question. I think I often find myself thinking about these apocalyptic scenarios of what is life going to be like in those cases. And I think this idea of wars being fought over water is, I've heard a lot of people say it as well. So I think that's really interesting.
Yeah, and it's a huge question for survival. But in terms of research, we really don't have a good understanding yet on how these extreme climate events will impact water quality in different types of lakes.
Definitely. Well, I think that is a great question for us to ponder, and hopefully we'll move ever closer to answering. And I know as you go through your career in science, answering all these interesting questions, you get the help from a lot of mentors, a lot of different people in your life. Mm-hmm. And I think these people are great sources of advice. So Sapna, is there one piece of advice that you can point to that you received at some point from anybody that was just the best advice that really helped you?
So I've had amazing mentors throughout my career. I've been very lucky. And I think the best advice that I ever got was from my postdoc advisor in Madison, Jake van der Zanden. I remember as a postdoc near the end, sort of feeling overwhelmed because there's just a lot of different things to do. And as you become a faculty member, you know, that just grows exponentially.
Right.
And he was always on top of everything. And a lot of the professors in the Center for Limnology were always on top of being great scientists. They took care of their families. They were great people. And they always gave time for students and public or whoever. And I wondered, how do you do that without becoming too stressed? And one piece of advice he had for me was that when he gets a task, so you get an email asking you to do something, mm-hmm. you put it into different time chunks. If it comes in and it takes 1 minute, just do it right away. If it takes 30 seconds, do it right away. If it takes 5 minutes, just get it off your plate, because as you've taken things off your plate, then you don't have to worry about them and you get rid of the stress of thinking, oh, I have so many things to do. Because all the little things that don't actually take that much time add a lot of stress to your life, but they're not actually that big of a deal to respond to.
Mm-hmm. All those little things can add up, though, if you don't take care of them immediately. Yeah,
exactly. And I thought that was great advice. And so I've been doing that since. Things then just don't pile up in the same way. You have your big projects that you need to do and you have deadlines for different time periods, but you take care of them as they come, and it helps you balance your work and life, because then when you're at home with your family or with your friends, you can focus on them rather than thinking about all the different little tasks that you didn't do that day.
Definitely. Well, Sapna, I think that is amazing advice. Someone gave me that advice as well. So now I open an email once, and if I can respond to it within 5 minutes, it's done and it's off my plate and I never think of it again. So.
Yeah, exactly. That's amazing that you got that advice too.
Yeah.
I think that a lot of people do this, but it's just not intuitive to you when you're a student or a postdoc.
Right. Well, listeners, definitely take this advice to heart. Very useful and can really help you organize your life and not feel so overwhelmed. So thanks for sharing that with us today, Sapna. And is there any last piece of advice that you want to leave our listeners with today, or one note of inspiration that you want to end our conversation on?
One piece of advice that I give to my students a lot, and something that worked really well for me, was keeping your options open. I always like having, in research and life, having a plan, A, B, C, D, because you never know where life is going to take you. And I always like keeping my doors open to see, if you never know what direction you may head. If you enjoy doing something, keep at it. Just because it may not fit into what you think your current life plans are, you never know how it might fit. I just like to keep that in mind and give that advice to students as well. Just keep your doors open and have backup plans. You might not necessarily go to medical school. What else might you like doing, as you know, when you're teaching as well? And it sort of works as for ecologists as well. And being a professor, you never know where things might lead you. So try to keep your doors open to working on things that you might like and working with people that you like. Something that I've learned from over the last 5 years is I've done projects with people that I really like working with. It just makes it fun. It makes science fun. It makes collaborations fun. And you can both learn a lot from each other working with nice people that are smart and fun to work with.
I like it. Wonderful advice to leave our listeners with. I think keeping your options open and keeping an open mind as you consider those options are both really important. And coming back to that theme of kindness again, definitely surround yourself with the kind of people that you want to work with. So fantastic advice.
Exactly. And get yourself a support system. I think that's important in all aspects of life, and especially in science. If you have a support system, you can get through anything.
Definitely. Well, listeners, take this advice to heart as well. And Sapna, can you tell our listeners now, if they want to learn more about you and your work, where should they go?
Sure. My lab website is sharmalab.wordpress.com, or you can reach me by email at sharma, SHARMA11 @yorku.ca.
Perfect. Well, listeners, definitely take advantage of checking out that website and getting in touch with Sapna if you have any questions for her. And Sapna, thank you so much for your time today. I really appreciate it.
Thank you. It was fun talking to you.
It has been a pleasure to have you on the show. And listeners, thank you for hanging out with us today. We'll see you next time on another episode of People Behind the Science. Your voyage to explore the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to chatting with you next time on People Behind the Science.